Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll find the characteristics of the polynomial function given to us in the form of this table of values. So as per the problem, use finite differences to determine the degree, sign of leading coefficient and value of leading coefficient for the polynomial function. Now here we have to use the finite difference method. So in that method, we have to calculate the first differences, second differences to find out the degree of this polynomial function. So let's start by finding the first differences. So for that, we'll add a column to this table and label that as first differences. Now the first differences are calculated from the y values. So for the first calculation, we do the second y value minus the first y value. So it's negative 16 minus negative 45. So this is the first step. So here minus minus becomes positive. So it becomes negative 16 plus 45, which is equal to 29. So now we have to repeat this step down this column. So next we do it for negative 3 and negative 16. So negative 3 minus negative 16. This is equal to 13. And then we do 0 minus negative 3, which is equal to positive 3. And then we do negative 1 minus 0, which is equal to negative 1. And then we do 0 minus negative 1, which is equal to positive 1. And then we do 9 minus 0, which is equal to 9. And then we do 32 minus 9, which is equal to 23. So we can see that the first difference values are not the same. And that means the degree of this polynomial function is not equal to 1. So now we'll have to calculate the second differences. And we'll calculate the second differences from the first differences. So the first step is, so we'll do 13 minus 29. So we always do the second value minus the first value. So this is equal to negative 16. And then we'll do 3 minus 13, which is equal to negative 10. And then we'll do negative 1 minus 3, which is equal to negative 4. And then we'll do 1 minus negative 1, which is equal to 2. And then we'll do 9 minus 1, which is equal to 8. And then we'll do 23 minus 9, which will be equal to 14. So now we can see that the second differences are also not the same. So that means the degree of this polynomial function is not equal to 2. So now we'll calculate the third differences. So for third differences, we'll use the second difference values. So the first step is, so we'll do negative 10 minus negative 16, which is equal to 6. And then we'll do negative 4 minus negative 10, which is also equal to 6. And then we'll do 2 minus negative 4, which is also equal to 6. And then we'll do 8 minus 2, which is also equal to 6. And then we'll do 14 minus 8, which is also equal to 6. Here we can see the third differences are the same. That means the degree of this polynomial function is equal to 3 because the third differences are constant. Now we have to find the sign of leading coefficient. Now the sign of leading coefficient is the same as the sign of the finite constant. Now in this case, the third differences are all positive 6. So since these finite differences are positive numbers. So that's why the sign of the leading coefficient is also positive. So this is a very important concept you need to understand and memorize. Now we can find the value of the leading coefficient, and for that we have to use a formula. So the formula is the finite difference, the constant finite difference equals A, which is the leading coefficient, times the n factorial, where n represents the degree of this polynomial function. Now the constant finite difference we got here is the 6. So 6 equals A times, and the degree of this polynomial function is 3. So 3 factorial. Now we have to evaluate 3 factorial. Now factorial is a mathematical operation in which we multiply the whole number on which the factorial is there by all whole numbers less than it. So that means 3 factorial can be expanded as 3 times 2 times 1. So we multiply that number by all whole numbers less than it all the way to 1. 3 times 2 times 1 is equal to 6. So in the next step, we can write 6 equals A times 6. Now we have to solve for A, the leading coefficient. So we'll divide both sides by 6 to isolate A. So 6's on both sides cancel each other out. So we are left with 1 equals A, or A equals 1. So this is the value of the leading coefficient for this polynomial function. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.